So today we're looking at k-values. Now k-values is the reverse of what we've been doing with normal distribution. With normal distribution we've been looking at functions that look like px is greater than, say, we get an answer and we find this area. When it comes to k-values, what we're looking for here is we're looking for this variable that we've been given with a normal distribution calculation. And in order to do that type of calculation, we need to use a function which we call inverse norm. So how do we know when we're using an inverse norm function? Well, we have a function that looks somewhat similar to this, where the k, or any other letter, is the unknown part of the function, and this here is your area. So when you get a function that looks similar to this is telling you that you have to start using what we call inverse normal distribution. Another thing that you need to take into consideration when we're looking at inverse normal distribution is what the sign here looks like. So in this case here, your tail can either be right, left, or it can be center. Okay, we're going to look at all three examples during this video here about how we approach this. But let's have a look at your calculator right now and see how we bring up on your calculator the inverse function. So on your calculator, what we do here is we click on 2 for statistics. We click on, let's go back again. Click on distribution, normal, and we want inverse norm. So what we're looking for here is we're looking for a tail. In normal CDF we don't have the tail in there, okay? So in this particular question here, your tail would be left. And the way that we change that is just going down onto the tail, and then you get the options of left, right, or center. So we click F1 and that takes us to left. We put our area in, and in this case here the area is 0.18. So 0.18, and if we have a mean and a deviation, we pop that calculation in. So when we're working with finding unknown variables, we're using this function of inverse norm. So let's do a couple of examples so you can see what we're doing. So we've got a question where we have a deviation of 3 and a mean of, what do I got for my mean? 15. First thing we want to do here is let's find out what the variable when it's less than k is equal to 0.2. Now, when we're working through these questions, always know that whatever you put into your calculator, you're going to get an answer. Okay? So it's really good to be able to go back and think about, well, does my answer make sense of what I'm talking about? So if we go all the way back and look at our normal distribution curve, and we plug in all this information, we have a mean of 15, we have a deviation of 3, which then leaves us with a kind of distribution that looks like this. What we're looking for here is, what could be the k value be if I have an area that's up to 20%? Remembering that this here is 0.15, 2.15, 13.59, 34.13. So I want to go up to 20%. So I think, well, it's got to be greater than 16%, because if I add all this up, that adds up to approximately 16. So therefore, it has to be between 12 and 15. The reason why I want you to think this is because this is the answer you're expecting to get when you do your calculation. And if you can see how this relates to your normal distribution, at least when you get a calculation, you can say, you know what, that makes sense. That's what I was expecting to get, that's what I did get. So let's put this question into the calculator and see what we actually get. So we are looking at a left. Your area this time is 0.20. Your mean or your deviation is 3, so we'll put 3 in there. And your mean is 15. Once you've done that, let's press calculate, and we get an answer. K is approximately 12.5, which is where we expect it to be, between 12 and 15. Just say, for instance, we made an error in your calculator. So if we went back, and instead of having left, we went right. Let's see what happens with your answer. We get 17.52, which is up around here. Now, if we're looking at this in the back of our head, we go, hang on, 20% is less than 50%. So my answer has to be less than 15. I'm getting something that is greater than 15. I've done something wrong. So this is where you have to make that connection between your normal distribution curve and what we expect the answer to be. A second example, if we had x was, let's say, greater than k, and is equal to 0.1. Again, let's think about this time. 10% coming from the left-hand side, so it's got to be greater than the highest 10%. So we're looking somewhere over this side here. So let's plug the calculator function in. So again, just press exit. We don't have to worry about changing the tail. It's right now. All we're doing here is changing this area. 0.1 and then enter. We get approximately 18.9. So 18.9, where we thought it would sit approximately, because this adds up between 13 and, so remember this is 13.59% between here and here, that's 2.5. So it sits where we're looking to fit. Our last example is where we have a central kind of calculation. So this here is an example of a left tail. This here is an example of a right tail. Let's now have an example where we're looking at a left tail. So if we have the probability of 15 minus k is less than or equal to x, which is less than or equal to 15 plus k with an area of 0.9. Now, how is this different to what we've done in the first two examples? Well, the difference here is we've got something in terms of the left-hand side of the distribution and the right-hand side. So this here is what we call a central tail. Our mean, our deviation doesn't change. What this does is it gives us two different answers. One that we can use to calculate the unknown k. And in each case, you should get the same answer. So if we go back to your calculator, this time we're going to go up to central, up to this, click central, change our area to 0.9, and then when we press enter, we should get two results. What this tells us is x1 is equal to 10.1 and x2 is equal to 19.9. So what we can do here is we can equate the lower part of the value with the lower end of your distribution, or the higher part of your value to the higher part of your distribution. In each case, you should get the same answer. So for instance, if we did 15 minus k and equate that to 10.1, then we get negative k is equal to, well, if we take 15 away from here, we should get something like 4.9. Negative 4.9, and then k is equal to 4.9. If we did the right-hand side over here, 15 plus k is equal to 19.9. If I then take that 15 away, I should get the same answer. So if you're not getting the same answer when you work on these two different types of calculations, then you've done something wrong. You haven't used the central function. So this is what we're working with in terms of k values. We're now introducing the inverse norm. We're reversing the normal distribution calculations we've done. In the next video, we're going to look at a couple more examples in terms of how we can use the normal distribution curve with z-scores. I'll see you now.